Okay, this is worksheet number 2. Find the limit as x approaches 0 from the left. Okay, so from the left, as I get closer to when x is 0, my graph is approaching -3. Number 2, find the limit as x approaches 0 from the right. So from the right-hand side, my graph, the y value is approaching 1. So this is asking for the total limit. So if the limit from the left does not equal the limit from the right, then the total limit is not going to exist. Find the limit as x approaches 1 from the left. So I'm going to pick up my graph and I'm going to keep on going until I get to 1. So I'm still not at 1, so I need to pick up here. Now I'm at 1. My graph is approaching 1 as its y value. From the right-hand side, as x approaches 1 from the right, it's approaching 1. Whoops. And so since my two limits from the left and from the right are the same, then the total limit would equal 1. Number 7, the limit as x approaches 5. It didn't tell us what side, so that means we have to check both sides. So as I approach 5 from the left-hand side, here's 1, 2, 3, 4, 5. Here it is right here. So from the left, it's 1. From the right, it's 1. So my total limit is 1. Now I want to find f of 1. This has nothing to do with the limit. It just wants to know when my x value is 1, what is my y value? They're looking basically for an ordered pair. So when x is 1, y is 1. F of 0, when x is 0, what is my y value? It's an open circle here, so it can't be this point. It has to be this point. So that is 1. Find f of -2. When x is -2, what is my y value? It is 0. I want to find the limit as x approaches 6 from the left-hand side. Okay, so here's 1, 2, 3, 4, 5, 6. So from the left-hand side, my graph is approaching 0. From the right-hand side, my graph is approaching 0. So the total limit, since the left and right-hand limits equal, then my total limit is 0. Now I want to find f of 6. So when my x value is 6, what is my y value? Well, since it's not an open circle there, it is 0. Find the limit as x approaches 3. It didn't tell me what side, so I have to check the left and the right side. So as x approaches 3 from the left, it's 1. From the right, it's 1. Even though it's an open circle, if there were cars traveling on this road, those two cars would still meet at that point. So my answer is 1. Then it says find f of 3. So when x is 3, what is my y value? Well, I don't have one because it's an open circle. So f of 3 does not exist. The limit as x approaches -1 is approximately, so as x approaches -1, so here's -1 right here from the left. I also have to check it from the right. It still meets that. I'm going to say that's what, -1.5 or -3/2. So now they're saying, okay, what is my point when x is -1? What is my y value? Well, it's actually that same point, -3/2. True or false? The limit exists as x approaches c at every c between 1 and 3. Okay, so here's 1. I'm just going to make a little mark. Here's 3. We're not including the endpoints because it's an open interval because of the parentheses. So in between these 2 points, does the limit exist for every one of those? And that is true. Okay, so now they've just changed the interval on us. Now they want us to look at -2 to 1. Does the limit exist for this open interval? So I'm not looking at endpoints. So I'm going to start at -2 and I'm going to go to 1. Does the limit exist everywhere between these 2 points? Well, it exists everywhere here, but right here at 0, it does not exist. And we know that from number 3. Okay, so true or false? Does it exist from -2 to 1? And that would be false. Okay, number 21. Okay, the limit as x approaches 9 of x, all of these should be direct substitution problems. Substitute your 9 in. My limit is 9. That's pretty easy. This one's going to be substitute my negative 30 in, so that's negative 30. Substitute my 2 in. There's no place to substitute my 2 in. So remember what this looks like. This is 5. This is a horizontal line at 5. And if I do this graphically by looking at the graph, as x approaches 2, isn't that just going to be 5? So that's one of our rules for limits. As the limit approaches a constant, your limit is that constant. So as x approaches 0 of 6, my answer has to be 6. 25, direct substitution problem. 12 times 1 cubed plus 1 squared minus 1. So 12 plus 1 minus 1. My answer is 12. 26, direct substitution problem. 5 minus, that's a negative 5, minus 1. So 3 times negative 6, negative 18. Okay, this is a direct substitution problem again. 5 plus 1 over 5 plus 2, 6/7. And on this one, I can't use direct substitution because I'm going to get 0 in the bottom. So anytime that happens, you must be able to factor or rationalize or something. Okay, I know that factors of 6, that when I add them, I get 5 are 3 and 2. I know my signs are the same and they are minus. So that's going to be x minus 3, x minus 2. My 3's cancel. So now I have x minus 2 left, and now I can use direct substitution to get 1. 29, I can't substitute negative 7 in here because that would give me 49 minus 49. So I must be able to factor. X squared minus 49 is the difference of squares. So when I factor the bottom, my x plus 7's cancel. And don't forget, when you cancel that x plus 7 on top, you have a 1 up there. Now I'm going to use direct substitution. Negative 7 minus 7, negative 1 over 14. And 30, this is a direct substitution problem. Cosine of pi times the sine of pi. Okay, well I know at pi, here's pi on my unit circle, that's the point negative 1, 0. So I know cosine is my x value, times sine is my y value, so negative 1 times 0 is 0. So that's problems 1 through 30. I'll do the next set in the next video.